Hey students, welcome back. This is a lesson on rational exponents and simplifying radical expressions. So let's start with rational exponents. Rational exponents are basically just exponents that have a fraction. Okay? So a rational exponent is just an exponent that is a fraction. Okay? So the exponent is a fraction. And it turns out that when the exponent is a fraction, that's the same as either a square root, a cube root, a fourth root, or a fifth root, etc. And basically whatever your denominator is going to tell you what type of root it is. So it's actually going to be a radical. Okay, so let's see an example of a rational exponent. Okay, so example. Use radical notation to rewrite this expression. Okay, so use radical notation. Use radical notation to rewrite the expression. Okay, and then here the expression, the first one we're going to do is pretty easy. So example number 1 is 4 to the 1/2. 4 to the 1/2. So this exponent is actually a fraction. This is the same as 4 to the 1/2 if you write it vertically like that. That's what it means. And like I was saying, this is actually going to be a radical. So the 1/2 power is actually the same as the square root. Okay, so this equals the square root of 4. Okay, and everyone should know that 2 times 2 is 4, so the square root of 4 has to be 2. Okay, so our answer here is 2. Now, how did I know it was a square root? I mean, I saw it was a fraction. How did I know it was a square root? Well, looking at the denominator, here the denominator is 2. So the denominator actually tells you what type of root it is. Okay, so let me write that down. Denominator indicates type of radical. Okay, so if the denominator is 2 of your exponent, then that means it's a square root. Because remember, the square root of 4 actually secretly has a 2 there. You don't write the 2, but it's secretly there. Okay, and then if it's any other number like 3 or 4 or 5, you do have to write it. So a cube root, a fourth root, or a fifth root, you would have to write it. Okay, but these problems, if you know how to do them, they're actually really easy. Like that one was super easy, hopefully. Okay, so let's take a look at the next one. So for this one, our exponent's denominator was 2, and that gave us a square root. So for example number 2, we're going to take a look at a different denominator. For this one, we're going to do 1 over 256 parentheses raised to the 1/4 power. Okay, so 1 over 256 parentheses raised to the 1/4 power. Now the first thing we need to do here is, because we have a fraction, not just for the exponent, but a fraction on the inside here, we need to distribute the 1/4 power to the numerator and the denominator. So that's what we're going to do first. So we distribute the 1/4 power to each exponent. Okay, so we get 1 to the 1/4 on the top, and then 256 to the 1/4 on the bottom. And you're allowed to do that because of the rules of exponents that we learned in an earlier lesson. So remember, basically the rules of exponents say that you can distribute your exponent as long as the numerator and the denominator only have one term. And because they only have one term, we were allowed to distribute. Now remember, 1 raised to any power is still 1. So 1 to the 1/4 is just going to be 1. Okay, and then in the denominator, we have 256 raised to the 1/4 power. Now what does that mean? Well, like I said, you look at the denominator of your exponent. So on the last one, our denominator was 2, so it was a square root. For this one, the denominator is 4, so it's a 4th root. Okay, so this one's actually going to be the 4th root of 256 in the denominator. So we have 1 over the 4th root of 256. Okay, so some of you probably already know how to do the 4th root of 256, but others might not know how to do it. So probably the easiest way to do it is with a calculator. But I want to show you how to do it by hand, just so that we can learn the math behind it. Okay, so the basic idea with the 4th root of 256 is you make a factor tree. Okay, so you make a factor tree for 256. Okay, so 256, if you're not sure what goes into it, you can divide it by, I think 16 goes into 256. So if I open up any kind of calculator, I do 256 divided by 16, gives me 16. Okay, so 256 factors as 16 and 16. All right, and then with your factor tree, the idea is you want to go all the way out until you have a total of 4 factors, because we want to cancel out the 4th root. Okay, so we're going to factor each of these 16s as 4 and 4. Okay, so each one of those factors as 4 times 4. Okay, so that means 256 is the same as 4 times 4 times 4 times 4. So that's 4 to the 4th power. 256 is 4 to the 4th power. Okay, and then what can we do with that? Well, we can plug it back in up here, and stuff's going to cancel out. So we're going to have 1 over the 4th root of 4 to the 4. And it turns out that if your root is the same as your exponent, they cancel out. Okay, so we can actually cross out the 4th root and the 4th power, and that gives us our answer, which is 1 over 4. Okay, so our answer is 1/4. Okay, and the rule that we're using there for radicals is basically if you have the nth root, so rule that we used, if you have the nth root of x to the n, then the radical and the n power cancel out as long as they're the same, and that just gives you x. Okay, so that's the rule that I use there. Now, if you don't want to go through all this work of doing it by hand, that's understandable. So how would you type this into a calculator? How would I do 4th root of 256? Well, one of the nice things about rational exponents is if you type them in correctly, you can actually do the whole thing on a calculator. Okay, so for example, up here, when we had 256 to the 1/4 power, we could have typed that into our calculator. So we would do 256, and then we would press the exponent button, and then we would do parentheses, and then we do 1 divided by 4, and then we end parentheses. So that gives us 256 to the 1/4 power. Press equals, and that gives us 4. Okay? So they got 4 on the calculator just the same way we got 4, but the way we did it took us a lot longer, right? So it probably would have been easier to type it into the calculator, but I did want to show you a factor tree just so that you would understand the math behind what a calculator does. But in reality, you might want to just type in 256 to the 1/4 onto your calculator rather than going through all this, because it's a bunch of extra work to write it out like this. Okay, and then for rational exponents, I just wanted to do a couple more examples. Okay, so let's do an example number 3 here. So for example number 3, we have 100x squared. Sorry, 100x to the 4th, not x squared. So 100x to the 4th with parentheses around it, raised to the 1/2 power. Okay, 100x to the 4th, parentheses, raised to the 1/2 power. Now what we have to do here is we actually have to distribute the exponent. Okay, so we're going to distribute the 1/2 to every single exponent inside of the parentheses. And we're allowed to do that because there's only one term. Even though there's more than one factor, there's only one term. So we're allowed to distribute the exponent. Okay, so we get 100 to the 1/2 times x to the 4th to the 1/2. Alright, and then remember, anything to the 1/2 power is the same as the square root. Okay, so 100 to the 1/2 power is the same as the square root of 100. And then for the x to the 4th to the 1/2 power, what we can do is we can multiply these exponents. So this is going to be the same as x to the 4/1 times 1/2. Because remember, if you're raising an exponent to another power, you multiply the exponents. And 4 is the same as 4/1. Okay, and then how do you multiply fractions? Straight across. So here, we're going to have x to the 4th over 2, so x to the 4/2. And then the square root of 100 is 10, because 10 times 10 is 100. So we have 10 times x to the 4/2. And 4 divided by 2 is 2. Okay, so we have 10x squared. Alright, and that's actually the whole problem. So 10x squared is your answer. Okay, so I just wanted to do one more example of rational exponents. So that was example number 3. Let's take a look at example number 4. So for example number 4, we actually have negative 27 raised to the 2/3 power. Negative 27 raised to the 2/3 power. Alright, and here, even though we have a negative, we can still do this problem. So probably the easiest way to do this, even though it might look a little strange, is if you're not going to use a calculator, the way you would do it is you would split up the exponent into 2 parts. So you can write this as negative 27 squared, and then put brackets around that and raise it to the 1/3 power. Now you might be wondering, well, why is that the same thing? Well, I'm raising an exponent to a power, so I multiply the exponents, and 2 times 1/3 is 2/3. So I'm actually allowed to rewrite it like this. Okay, and then for negative 27 squared, you can type that into your calculator. Okay, so parentheses, negative 27, end parentheses, squared, and that gives us 729. Okay, so the minus actually goes away because when you square something, you have a minus times a minus, which is a plus. So we have 729 raised to the 1/3 power. Okay, and then what does the 1/3 power mean? It means the cube root of 729. And if you want to just be lazy about it, you can do this on your calculator. So we would type in, if we want to use our calculator, we would just do 729, and then we would press the exponent button, and then parentheses, 1/3. So 1 divided by 3, end parentheses. Press enter, and we get 9. Otherwise, if you don't use a calculator, you have to make a factor tree. And that can be tedious with a big number like 729. But using the calculator is the fastest way to do this here, so our answer is 9. Okay, and actually at the beginning of the problem, we could have just done the entire thing right at the beginning on our calculator. So if we do negative 27 to the 2/3, your calculator should also give you 9. So here, let me show you. So like on this calculator that comes with the computer, we do parentheses, 27, negative, end parentheses, and then we press the exponent button, and then we do parentheses, 2/3, so 2 divided by 3, end parentheses, and then press enter. And that gives us 9. So see, if we want to just type that into our calculator right away, we actually get to skip all these steps here, and it gives us the answer right away, which is really fast. Okay, so that's pretty nice. All right. Okay, so that completes the portion of the lecture that's about rational exponents. Okay, so our next topic is going to be simplifying radical expressions. Okay, so new example. Simplify each radical expression. Simplify each radical expression. And what's a radical expression? Well, it's just an expression, so it's got multiple things going on. It's an expression involving square roots or cube roots or fourth roots or any kind of roots. Okay, so radical expression just means it's an expression that has a radical, or more than one radical. It could have 2 radicals or 3 radicals. And for our first example, we're going to be doing multiplication. So for our first example, we're going to have root 5 times root 6x. Okay, root 5 times root 6x. And they want us to simplify this. So we're going to have to learn some new rules. We're going to learn rules for radical expressions. So since we're multiplying here, the rule we're going to use is if you have root x times root y, that equals the square root of xy. And that doesn't just work for square roots, that works for any radical as long as it's the same radical. So if you have the nth root of x times the nth root of y, that equals the nth root of xy. So basically, when you're multiplying them, if they are the same type of radical, you can sort of factor out the radical from the whole thing so that everything is affected by the radical. Okay, so like here, instead of writing it as 2 separate square roots, we can rewrite it as a single square root. Okay, so this is going to give us root 5 times 6x. Okay, so the square root of 5 times 6x. So all I did there was I took the 2 radicals and I combined them into 1. And then we should all know that 5 times 6 is 30. So we have the square root of 30x. And is there anything else we can do there to simplify it? Well, no, because if you look at the square root of 30, 30 is the same as 10 times 3. And you can't take the square root of 10 and you can't take the square root of 3. So root 30x is as simplified as it gets. Okay, so root 30x is actually our answer. And this rule that we used here is sometimes called the product rule. So on your homework, they'll call it the product rule because the word product actually means multiplication. Okay, so they're multiplying here, and multiplying outside the radical is the same as multiplying inside the radical. So these two radicals multiplied together are the same as a combined radical where you multiply on the inside. Pretty cool, huh? So it's not too hard for most people. Okay, so let's see example number 2 of simplifying radical expressions. So for example number 2, we have the square root of 5 over x times the square root of 3 over y. Okay, the square root of 5 over x times the square root of 3 over y. Well, even though we have fractions here, I know people get scared when they see fractions. This is actually not so hard. The reason this isn't so hard is we do have fractions, but we know how to multiply fractions. You just multiply fractions straight across. So first of all, we combine everything into a single radical. So we're going to have the square root of 5 times 3 on the top, and then on the bottom we have x times y. So all I did there was I took the multiplication on the outside and combined it into multiplication on the inside, and then multiplying fractions, we do that straight across. So I multiply on the top and I multiply on the bottom. Okay, and then we know that 5 times 3 is 15. Okay, so on the top we have 15, and then on the bottom x times y is xy. So we actually have the square root of 15 over xy, and that's our answer. The square root of 15 over xy. And later on in the book, they might have problems where you would rationalize the denominator, which would mean you'd have to get rid of the square root in the denominator. But here they're not asking you to do that, so this is actually how they want you to leave your answer. Okay, so this is going to be our answer. Square root of 15 over xy. Okay. Cool. So I think you should be good for that and a couple more of your homework problems. Okay, so let's go on to example number 3. So example number 3 is the square root of 2 over 9. The square root of 2 over 9. So now for this one, we're actually going to need a new rule. So the new rule that we're going to be using here, the new rule we're going to be using here is if you have the square root of a fraction, you can distribute the square root to the top and the bottom. Okay, so if you have the square root of x over y, this is equal to root x over root y. Okay, so that basically just says that you can distribute the radical to the top and the bottom. And that's not just true for square roots, that's true for any kind of radical. So if you had the nth root of x over y, that would equal the nth root of x over the nth root of y. Okay, so here we would have root 2 over root 9. Right, so just distributing the square root to the top and the bottom. And then we can't simplify root 2 because you can't take the square root of 2. But I think everyone knows that 3 times 3 is 9. So the square root of 9 in the denominator is going to be 3. Okay, so we actually get root 2 over 3. And that's our answer, root 2 over 3. So it's a pretty easy problem. In fact, most of these are easy as long as you know the tricks, what you're supposed to do. Okay. So let's jump into another one. Okay, so example number 4 of simplifying radical expressions. For example number 4, we have the 4th root of x cubed over 256. The 4th root of x cubed over 256. So here we have a fraction, and we have a radical applied to it. This time it's a fourth root rather than a square root. But we can still distribute it to the top and the bottom. Okay, just like we did on the last problem. So we're going to have the fourth root of the numerator, so the fourth root of x cubed, over the fourth root of the denominator, so that's the fourth root of 256. And remember, we already calculated the fourth root of 256. We said it was 4. Okay, and then for the fourth root of x cubed, you can't really simplify that. Nothing's going to cancel out there. It's really the same as x to the 3/4, but they want you to leave it as a radical in this problem. So we're going to leave it as the fourth root of x cubed on the top, and then on the bottom, we're going to have 4. So we have the fourth root of x cubed over 4. And remember, we just did the fourth root of 256. But if you don't remember it, you could just do 256 exponent parentheses 1 divided by 4 end parentheses equals 4. So 256 to the 1/4 power is 4. Okay? So there, we're good there. And that's actually the whole problem. Okay, so let's go on to example number 5. Go on to example number 5. So for this one, we actually have the square root of x to the 4th times y over 144. The square root of x to the 4th times y all over 144. Okay, so the square root actually applies to the whole fraction here. Once again, you're allowed to just distribute the square root, and because there's 2 factors on the top, we can actually distribute the square root to everything. So I can rewrite this as the square root of x to the 4th times the square root of y. Okay, so we have the square root of x to the 4th times the square root of y on the top. And then on the bottom we have the square root of 144. So you can literally just distribute that radical to every single thing. As long as the top and the bottom only have one term, and these only have one term. Remember, this has more than one factor, but it doesn't have more than one term. So you're allowed to distribute the radical to everything. And then I'll tell you a little trick about square roots. If you have the square root of an exponent, you actually just end up dividing by 2. Okay, so for this 4th power here, because we're raising it, it's raised to the 4th power, and then we're taking the square root, we're basically just going to be dividing the exponent by 2. Okay, so divide, so square root means divide exponent by 2. Divide exponent by 2. Okay, so what's that going to mean? We're going to get x to the 4 divided by 2. Okay, so we have x to the 4 over 2 times the square root of y all over the square root of 144. But most of you should already know that the square root of 144 is 12, because 12 times 12 is 144. So our denominator is just going to be 12. And then, of course, 4 divided by 2 is 2. Okay? So we actually have x to the 4 over 2 is x to the 2. So we have x squared times the square root of y all over 12. And that's going to be our final answer. And we can't simplify the square root of y because it simply doesn't have an exponent to divide by 2, so there's nothing we can do to simplify it. So that's actually the whole problem. Okay? All right. So we're going to keep going. So let's go on to example number 6. That was example number 5, right? Yeah, the one before that was example number 4. This one was 5. The next one is 6. Okay, so for example number 6, we have the square root of 24. Now you might be wondering, well, what on earth do I do here? This is a different type of problem from the earlier ones. We still want to simplify, but we're going to have to take a different approach here. So the square root of 24 actually can be simplified, and the way you simplify it is by factoring. Okay, so the trick here is to factor. And the way you factor is important. So you need to factor it in a way so that you can take the square root of something. So something needs to simplify. Okay, so we factor so that a square root simplifies. We factor so that a square root simplifies. So if you think of the ways you could factor 24, if we did root 2 times root 12, that's not going to work because you can't take the square root of 2 and you can't take the square root of 12. So you wouldn't want to factor it as root 2 times root 12. So that's why I say you need to factor in a certain way. So you try factoring in different ways until you find something where a square root simplifies. So what's another way of factoring 24 besides 2 and 12? Well, instead of 2 and 12, how about we do 6 and 4? Or 4 and 6. Let's rewrite it as root 4 times root 6. Now here we can see that something is going to simplify. What is the square root of 4? We all know that 2 times 2 is 4. So that means the square root of 4 is 2. And that actually does simplify. So we get 2 times the square root of 6. And then you can't simplify the square root of 6 because it's the same as root 2 times root 3. And root 2 and root 3 don't simplify. Okay, so because root 2 and root 3 don't simplify, we leave it as root 6. So our final answer is going to be 2 times root 6. Okay. And as you could see, if we factored it some ways you can't simplify, some ways you can. So you have to just keep factoring it different ways until you find something that does simplify. That's the trick there. Okay, cool. So let's go on to the next one. Okay, problem number 7. 3 times the square root of 27. So the 3 is out front, and it just sits out front, but the square root of 27 is what we need to work on. So once again, we need to factor the 27 in such a way that we can simplify a square root. So if you think about 27, 1 and 27 doesn't work because you can't take the square root. But if we do 9 and 3, we know that we can take the square root of 9. Okay, so we're going to rewrite it as root 9 times root 3. And then we still have a 3 out front. Okay, so we have 3 times root 9 times root 3. Okay, because there's still a 3 out front. And then the square root of 9 is 3. So we actually have 3 times 3 times root 3. 3 times 3 times root 3. And then 3 times 3 is 9. So we actually have 9 root 3 now. And that's going to be our final answer. That's actually how they would write it on my math lab. So 9 root 3 is our answer. So that one was a lot like the last problem. The only difference is we had this 3 out front, and we ended up needing to multiply that at the end. So after we simplified the square root, then we saw that we had 3 times 3, which is 9. Okay, so let's go on to example number 8. There's some new tricks to learn in example number 8. So for example number 8, they start throwing in a variable again. Okay, so for number 8, we have the square root of 49 x to the 9. The square root of 49 x to the 9. Alright, so remember, if you have the square root of things multiplied together, you can actually distribute the square root to each part. So this is the same as the square root of 49 times the square root of x to the 9. Okay, and I think we should all know that 7 times 7 is 49 from our times tables. So the square root of 49 is just 7. But then the weird part of this problem is, how do you deal with the x to the 9? Well, the way you deal with the x to the 9 is, once again, you want to factor it in such a way that we can simplify a square root. And the trick here is to actually factor it as the square root of x to the 8 times the square root of x. Why am I allowed to do that, and why am I doing that? So I'm saying we want to write it as the square root of x to the 8 times the square root of x. Well, first of all, I'm allowed to do it because, remember, x to the 8 times x equals x to the 9. So I'm allowed to do that because the square root of x to the 8 times the square root of x is the square root of x to the 9. So why did I do it that way? Well, because I know that the square root of x to the 8, I'm just going to go ahead and divide the exponent by 2, and I know that 2 goes into 8. So I can actually simplify this one. But that's kind of tricky. It's a trickier problem. So here, for the x to the 8, we're going to go ahead and divide that exponent by 2. Divide by 2. Alright, so we're going to have 7 times x to the 8 over 2 times the square root of x. Okay, and then 8 divided by 2, of course, is 4. So we're going to get 7 times x to the 4th times the square root of x. So the trick there to this problem, what makes it tricky, is when your exponent is actually odd, then you have to rewrite it as 1 less times x. Okay, so the exponent was 1 less than 9, so I wrote it as x to the 8 times x. And then because x to the 8 actually has an even exponent, I was able to divide that by 2 and simplify it. But if you started with this odd exponent, we couldn't simplify it because 9 is an odd number, and you don't want to write your answer as 9 over 2. You don't want to write it as x to the 9 over 2. Okay, so we have 7x to the 4th times the square root of x, and that's our final answer. Okay, cool. Okay, so just to reinforce that idea, I wanted to do another example that involved that. Okay, so example number 9. So for example number 9, we have the square root of 36 a squared b to the 5th. The square root of 36 a squared b to the 5th. So now this problem looks intimidating the way it's written, but it's actually pretty similar to the other stuff we've been working on, so don't get too scared by it. So if we split this up into multiple parts, it's not too bad. So we can distribute the square root to each factor. So we're going to have root 36 times root a squared times root b to the 5th. Okay, so square root of 36 times the square root of a squared times the square root of b to the 5th. Alright, and then the square root of 36 is just 6. And then the square root of a squared is a. And then the only tricky part is the square root of b to the 5th. But for the b to the 5th, once again, because the exponent is odd, we're going to rewrite it as b to the 4th times b. So we're going to rewrite it as the square root of b to the 4th times the square root of b. And the reason we're doing that is because we need to divide by 2 for the exponent. So here, the square root of b to the 4th, we need to divide that exponent by 2. So we're going to get b to the 4 over 2, which is 2. Okay, so we have 6a b to the 4 over 2 times root b. And even though we couldn't do the square root of b to the 5th because it was an odd power, we can do the square root of b to the 4th because it's an even power. And that one gave us b to the 4 over 2, which is b squared. Okay, so we have 6a b squared times root b. 6a b squared times root b. Okay, and that's almost all of your homework. That's almost all the types of problems on your homework. So I just wanted to do one more example, example number 10, just to make sure you're set for your whole homework. So for example number 10, we have root 35 over root 5. Root 35 over root 5. So the thing is here, you might not be sure what to do, but this is actually not so bad. All you have to do here is sort of factor out the radical from the entire fraction. So this is the same as the square root of 35 over 5. You can factor the square root out of the whole fraction. And then what's 35 divided by 5? Well, from our times tables, we should know that 7 times 5 is 35. So 35 divided by 5 is 7. Okay, so we actually just have the square root of 7. And the square root of 7 is not something you can simplify, because you can't take the square root of 7. So root 7 is our answer. So even though this one's towards the end of your homework, it's actually a really easy problem if you know the trick. Okay, so that's the whole thing. Thanks for watching.